Hello, welcome to Chapter 3, Analyzing and Representing Data with Measures, Part A, Measures of Center. In the previous chapter, we saw different graphs used to represent and analyze one numerical or categorical variable. This Chapter 3 focuses in how to use measures of center, position, and spread to analyze the distribution of one numerical variable. I say 1 as opposed to 2 because chapters 4 and 5 are about analyzing the relationship between two variables. I divide this chapter in 3 parts. We are now in Part A, Measures of Center. The goal of a measure of center is summarizing the whole distribution in a single value. We expect all the other values to fluctuate around this one, some of them above, some of them below. In this course, we will work with 3 measures of center, the mean, the median, and the mode. Let's introduce them with the help of this distribution. Exercise 1. Express this distribution with a frequency table. We saw this before. There is 1 3, 4 4s, 2 5s, 1 6, 1 7, 1 8, and 2 11s. Exercise 2. Express it with a dot plot. This is also practicing what we saw in Chapter 2. Here is the 3, the 4 4s, the 2 5s, the 6, the 7, the 8, and the 2 11s. Exercise 3. Find the following 3 measures of center. The first one is the mean, sometimes called average. Notice that there are 3 notations typically used for the mean: mu, x bar, and e of x, expected value of x. We use them in different scenarios. The mu is commonly used for the mean of a population, the x bar for the mean of a sample, and the e of x for something that is neither a population nor a sample, usually something about the future. Then we call it expected value of x. Because sometimes it might not be clear if something is a population or a sample, I just write mean. So let's get the mean of this distribution. You probably know how to do this. We add up all the values and then we divide by the total amount of individuals. 3 plus 4 plus 4 plus 4 plus 4 plus 5 plus 5 plus 6 plus 7 plus 8 plus 11 plus 11. All of it divided by 12. A common mistake here, especially when students look at the frequency distribution, is dividing by 7, because they see 7 different values here. There are 7 different values, but some of them have repetitions. You need to count the repetitions. In other words, you need to involve the frequencies. In a similar way, a common mistake is adding only 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 11, not including the repeated 4s, 5s, and 11s. Be sure to use frequencies. Be sure to include the repetitions. Notice that you can shorten this fraction if you express 4 plus 4 plus 4 plus 4 as 4 times 4, and the 5 plus 5 as 5 times 2, and the 11 plus 11 as 11 times 2. That's why we commonly see 2 formulas for the mean. One does not use frequencies. It just adds all the values, repeating as many as necessary. The other multiplies each value times its frequency. Both are equivalent. If you do this, you will see that the mean is 6. The second measure of center is the median, as known as the middle. It is commonly denoted by x hat or Q2. There is no formula, there is a procedure which I explain with the help of what I call the scheme. If we have 12 values, how do we find the middle? We divide the 12 positions in 2 halves. The scheme will be 6 and 6. Do we have one very individual in the middle? No, because 6 and 6 is already 12. So we will have to pick these 2 as the middle positions. Now the question is, what positions are these? It's clear that this is the 6th position and this is the 7th position. A common mistake here is saying that the median is 6 and 7 or 6.5. Not at all. These are only the positions. The positions in which the median will lie are the 6th and the 7th. Notice that these 6 and 7 don't come from our particular distribution. They are valid for every distribution with 12 values. So the question now is, in our particular distribution, what are the values in the 6th and 7th positions? Let's take a look here. 1st, 2nd, 3rd, 4th, 5th, 6th, and 7th. As you can see, the 5 and the 5. We do the average of both and we get that the median is 5. The mode has neither formula nor procedure. You just find the value with the highest frequency and that's it. In this case, it is clearly the 4. Notice that in this example, mean, median, and mode are different each other. Notice also that the mean is more to the right than the median. That's to say, it's greater than the median. In the previous chapter, we studied why, because this distribution is right skewed. Exercise 4. Let's see now an interesting property of the mean. Let's introduce the concept of distance from the mean. How far is this 3 from the mean, which is 6? Clearly, -3, because 3 is 3 units below 6. How far is this 4 from the mean? -2, because the 4 is 2 units below the 6. The formula is value minus mean. Reasoning the same way, you will see that these are the other distances from the mean. Let's add now all the positive distances. 2 individuals are 5 units away. This means 10 units away in total. With 2 more here and 1 more here, a total of 13 units. Let's add now all the negative distances. 2 individuals are 1 unit below the mean, 4 individuals are 2 units below the mean, and 1 individual is 3 units below the mean. This is a total of -13. Here you see both calculations. So, what's the total sum of all the distances from the mean? -13 plus 13 equals 0. The sum of all the distances from the mean equals 0. Is this always true or only in this example? It's always true. It's an important property of the mean. In some books, they call the mean the balancing point because it balances all the distances. In other words, all the positive distances cancel all the negative distances. Exercise 5. In the dot plot in exercise 2, mark the mean and graph all the distances from the mean. The mean is here. These are the positive distances. These are the negative distances. Again, the positive ones will cancel exactly the negative ones. Exercise 6. Here we have a distribution of salaries for baseball players in the USA. The mean is marked. It's a bit more than $3 million a year. If you are playing baseball and you are trying to become a professional, you may be excited about this average salary. The problem is that if tomorrow you get hired as a professional baseball player, the mean may not be a good indicator of how much you can expect to make. Why? We introduced this idea in the previous chapter, because the mean will be alienated by those players that make 10, 20 or more than $30 million a year. This brings question A. Mark the place where the median will fall. Notice that this first column has more area than all the other ones combined, so the median will fall somewhere in the first class. So the median is less than $1 million a year, and we don't know how much less. It might be $50,000 a year, it might be $100,000 a year, the histogram does not say. Letter B. What measure would in this case be a better representative of the salaries of baseball players? The median, because of how strongly skewed the distribution is. Letter C. What's the main advantage of the median compared to the mean? The median is more resistant to extreme values, outliers or tails, while the mean is easily alienated by them. Letter D. What's the main advantage of the mean compared to the median? The main advantage of the mean is that it is affected by every single value, so no value is disregarded. For example, we would never want to use the median for the final grade of a student. Imagine that there are 5 exams. In the first one, the student gets 60. In the second one, 65. In the third one, 67. This is a nice trajectory. This student may easily pass. But if we use the median, he will never pass. Even if he gets 100 and 100 next, the median would still be 67.